plate includes several unique features to ensure stability of the finger. The slanted sketch allows for the plate to be centered at the wrist and meet where the index finger would be. The curvature at the top provides a support for the hinge to sit on, with 2 holes for the hinge to be screwed into. The middle allows for the plate to be lighter. Here, a side flap would be inserted, and that flap is fed the palm Velcro strap. The holes allow for the hinge to be created with a post running down. Top hole allows a string to be threaded through it. The side extrusion with a single hole allows for the start of another Velcro strap to be screwed in. This strap runs across the palm of the hand and meets with the other side extrusion's flap. Bottom extrusion and cuts with the holes allow for the Velcro strap to run through and be screwed in. The edges are filleted as well.
This is our left flap design for our assembly. We have our initial boss extrude, which accounts for our foundation to build everything else off of. We have our second boss extrude and sketches, and these are both extruded, then filleted, and cut with 1 millimeter diameter size holes, or slightly bigger than that, to account for our 1 millimeter rods will be threaded through, where the base plate will be sitting here and here, with a 1 millimeter rod being threaded through to allow the flap to move freely to account for hand size, Velcro tightness, etc. We have our next sketches and boss extrudes, and these are both filleted, and this is where the Velcro will sit in between to allow it to be threaded through. And to allow it to be kept in place, we have our last boss extrude, which is a pole, and under here, the Velcro will be threaded through and allow it to be wrapped around the hand.
Okay, this is our hinge. It attaches to the top plate as well as the bottom segment of the finger. Going through the first part, it's a 12.7 millimeter semicircle that extends upwards. Reason we created this was so that it matches the dimensions and the shape of the hinge, and that way it can sit on top of it. Onto the next piece, we have the extension. So the extension is 3 millimeters away from the semicircle and matches the thickness of it. The reason we created it was so that the bottom portion of the hinge has somewhere to be. Otherwise, if it was directly under here, it would be interfering with the top plate. Onto the next piece is the bottom portion of the hinge. It's a 12.7 millimeter circle with a rectangle on top of it. That's 4.32 millimeters away from the rest of the hinge, as well as 2 millimeters thick. The reason we created this was so that the bottom segment of the finger has somewhere to attach onto on the hinge. Onto the next piece is the first cut. So the first cut was made for the screws, so it has somewhere to be on the hinge. It's a 2.5 millimeter circle, thus matching the diameter of the screw itself. I created it using some construction lines, another construction line. I found the midpoint, made the circle coincident. I then created a center line and then mirrored it to the other side. Onto the next piece, we have the second circle. So these two circles are 1.6 millimeters in diameter and are made for the screw to go through the hinge. I first created them by matching the center point of this inner circle to this outer circle, created a center line, and then mirrored it to the other side. And from there, the screw should be able to go through by using the cut feature. For this piece, we have two circles that are made for the screw to attach to the bottom segment of the finger. The first circle is 2.5 millimeters in diameter. I then created a center line and then mirrored it to the other side. The next two circles, I created a 1.4 millimeter circle that matches the center point of this outer circle. I created a center line and then mirrored it to the other side. And these circles were all made so that the screws can fit through the hinge and attach to the bottom segment of the finger. The next feature is the hole for the string to pass through. So we have a 2 millimeter circle over here, and what it does is that I cut it through all, that way the string can pass through. I made it about 3.1 millimeters away from the top of the hinge, and this way it matches the dimensions of where the hole is on the top plate itself, and it's cut through all for the string to pass through. The next feature is the fillet. We have one over here and one on the back side of it. Originally, it was an L shape, just connecting both this piece and this piece together. But with the fillet, it just looks a lot nicer and adds more comfortability for the hand over here. And that's our hinge.
All right, so this is our third part of the finger, the base, which connects to both the second part of the finger as well as the knuckle part. So let's go down the tree. We have our original boss extrude, which creates the full base of our structure. We have a cut extrude right here, and this creates a hole for where a spring can be fed through. We have a boss extrude, and this allows us to create our hinge portion, well, the base of our hinge portion. And this allows us to connect to the second piece. We have a cut extrude right here. which we create holes through, for which posts can go through and connect our hinges together. We have a fillet at the end of the extrusion of our original boss extrude to stop overhangs, or else there would be an overhang right here. We have a boss extrude right here, and this creates a stop for where our finger can be compressed more than that in the opposite direction, but it can be compressed this way in the forward direction. We create a sketch down here through which we can create our tapped holes, and these tapped holes are very important because that's where we put our screws through. We create a plane over here at an angle. And the reason we put it at an angle is it allows us to create a cut extrude like this at an angle. And this is through which our wire is fed through from the top to the bottom of the finger. And it's put at an angle so there'd be less friction if it was going straight. So that's why we put it at an angle. We also have another cut extrude right here, and this allows us to make sure it's a route for our thread to go through, and this allows it to stay in a kind of the central position of the whole bottom side of the finger. We also have another plane up here, and this plane allows us to create a sketch as well as extrude this area through which we put a post through. And this post allows us to keep the spring that's inserted in this hole in place without moving it. Then we have our boss extrude right here, and we have two boss extrudes. And what these do is they create a circular shape around our hinges. And this allows us for each side of the hinge hole to be in equal distance or length to make sure it's rigid on all sides and not thinner or thicker in some parts. We also have one last boss extrude right here. And the purpose of this box extrude is to create a loop or a hook for our canvas wrist straps to be fed through from the bottom to the top and then back down. And this allows us to secure the whole piece to the palm of our hand and make sure that the whole finger stays connected securely. And it's again for the third piece of our finger. Thank you. All right, so this is going to be the recording for the second finger. So let's go down the tech tree, the tree. We have the boss extrude first, and this creates the whole base for the structure. And it creates this hole as well. And this hole is where we feed through our wire, which will then allow it to compress and extend. We also have another boss extrude right here. This creates the hinges for our part for the top side. And this will be used to help connect our pieces together. This is the cut extrude through it, where a post will go through. So that hinges, like this one on this side, can fit through here and be locked in place. We also have a fillet on the top to make sure that there's no overhangs from the original boss extrude we have up here. We have a cut extrude right here, and from this is where our spring goes through, so that there's a spring on each side, which helps compress our finger and make it stay straight. Right here, we have another boss extrude with a hinge on the opposite side, doing the exact same thing as the first side. We have the cut extrude for the hole as well, similar to the other side, and the fillet that makes sure there's no overhang. We also have another cut extrude here for a spring on the other side, since this is the middle finger part of the three fingers. We have another boss extrude right here. What this allows is for the finger to not over compress, allowing it to stay straight at most. But if it wants to be bent, it can be bent the opposite way, but not this way. I created a plane right here, and what this allows us to do is create a sketch, which allows us to make these holes. And these holes where posts go through, so that these posts can keep the springs in place without letting them move around, and this will allow for the whole thing to be more rigid. We also have this boss extrude right here, and what we did is for these hinges, we made a circular shape so that each side would be the equal length overall, and this allows it for it to be more rigid rather than having thinner and thicker pieces all overall. And we did the same for both of these sides, where we created a circular extrusion on this side and a circular extrusion on this side to make it all stronger overall. And this is for the middle finger piece.
This is the topmost design of our finger. We have all these planes inserted as well as all these sketches inserted to utilize the loft feature to create the rounded off tip to allow it to look more realistic. We have our next sketch as well as a cut extrude to allow the spring to be threaded through, and that will allow for the movement while also connecting it to the middle section of the finger. We have our next sketch, which also acts as a connecting section, with it being cut out and filleted to have the post run through this finger as well as the middle section to connect them together. And then we have our cut extrude on the opposite side to allow the post to be threaded through to keep the spring in place. And then we have our boss extrude on the opposite side, which allows for the string to be threaded through and has a knot at the top, and then is connected through the bottom half of the finger and up through the bottom section to allow it to move when being pulled on by the wrist. And then we have a cut extrude for that as well. And then once again, this is just the boss extrude for the connecting part with the post.
Okay, so I'm gonna go over the assembly mates. The first one I did was a concentric mate right here. And what this would do is it would make sure the flap actually attached to the top plate through this portion right here, which would allow for that movement. Then obviously I wanted to flush it out. So I used the coincident and that allowed for basically like this perfect connection with the top plate and the flap. After that, I added a post in the middle, which would actually take form of like a metal post on the actual design. But basically, I wanted a concentric so it would fit through the holes that were attached beforehand. And then I just made it coinciding with the top plate right here, just so it could flush out at the top. In case there's like some excess skin, you wouldn't want the irritation up here and instead down here. The next mate I did was a concentric mate right here, and that attached the hinge to the actual top plate, and it was basically through the screw point where they would be attached. I was having an issue at first where it would just kind of rotate all around, so then I made a parallel mate in between the actual hole for the string. I think there's a better view over here of it, and that actually locked it on pretty well, and it didn't allow it to move anymore. So then I was just able to just kind of flush it out with the coinciding mate, making it attach perfectly to the top plate. After that, I would move on to like the finger. So the first mate I did was a concentric mate, and this was done to the actual screw in which the finger, or the bottom segment of the finger attaches to the top plate. Once again, I had that issue where it was just kind of going all around in circles. So I made a parallel mate between the two lines because of this strap right here. It actually flaps into here and kind of attaches to the pivot just for extra structure. So we'd actually glue it on here. So there's a little indent in the pivot and or the hinge, my bad, in the hinge. And what that would do is make sure that the strap would actually be attached, and it helped with the actual assembly since it would attach really well. Then I made a coincident mate just to flush it out because it was no longer moving around in circles. So that just flushed the hinge and the actual bottom segment of the finger. The next mates were just kind of repeated over and over again for the rest of the finger. But the first is a concentric mate on the actual connections between the fingers. I would make sure that they were just in line concentrically, and then I would just make a coinciding mate just to make sure they flushed out together and fit perfectly in that gap. Once again, I repeated that for the top finger, coincided it to flush it out. And then the final mates I would make are actually for these posts that would provide extra structure for the finger. And how I attach them, or what mates I use for that, I began with a concentric mate, allowing it to fit perfectly within it. And then I added coincident so it would be flushed out with the end. And then finally, because I know those were not supposed to be rotating parts, I added a parallel attachment, and then that would make sure it was flushed out with the actual front plate of this design. And overall, that allowed for this to no longer move, and the only moving parts we wanted in our assembly were the actual finger and the hinge. So if I move over to the motion study, you can see how those are the only moving parts. And that is everything. Thank you.